Welcome back. This is the video for page 2 of your 6.2 notes, where you're learning to multiply a decimal number by a decimal number. In these notes, we're going to work more with strategies to solve this using a simpler method, so you don't have to draw it out every single time. So go ahead and get your supplies ready. On the next slide, we'll continue our notes. Now, as we continue this skill here on page 2, I want to start looking at this in an easier way, because I can't draw all that grid out every single time and try to cut each piece into smaller pieces. That was a lot of work, and that's not going to work for most of our problems. So this time, let's think about what the numbers really mean. So for this one, we have a new problem. We have 7 25 hundredths times 3 8 tenths. And so I want to think about this first number. It's 7 25 hundredths, but what if I thought of it like 725 tenths hundredths? What if I thought of it like 725 hundredths? And then my 3 8 tenths, what if I thought of that like 38 tenths? What if I told myself I don't want to multiply and do all the grids for everything? I want to think of 725 times 38. I'm just going to do the math with my standard algorithm, and then I'll go back and deal with the decimal point. So that's what I'm going to do. I'm just going to think about my 725 and my 38. And I'm just going to use standard algorithm. 8 times 5 is 40. 0, carry the 4. 8 times 2 is 16, plus 4 more is 20. 0, carry the 2. 8 times 7 is 56, plus 2 more is 58. All right, I multiplied by the 8. Now I can multiply by the 3. I'll place my placeholder 0 the hero. 3 times 5 is 15. 5, carry the 1. 3 times 2 is 6, plus 1 more is 7. And 3 times 7 is 21. And add it all up. 0, 5, 15, carry the 1. 1 plus 5 is 6, plus 1 more is 7, and 2. So now I've got this number. I'm going to draw myself a line, and I have 275,000, nope, 27,550. But now, what if I thought of that like hundredths? So if I asked myself, well, what would 27,550 be if I turned it, oops, sorry about that, if I turned it into hundredths? Well, to do that, I'm going to think about my place value line. And I can put my decimal point, and I've got tenths and hundredths. So my 0 goes over here, and then I've got my 5, and then I've got my 5, and my 7, and my 2. So now I applied the hundredths. I turned it into hundredths. But I also have to remember that I multiplied by tenths. So to do that, I want to move everything back another place value place. This one I moved my decimal point 2 places to turn it into hundredths. And since tenths are just one more place value jump, I'm going to do that. I'm going to move my decimal point one more place, which leaves me with 27.550. So that's 27 and 550 thousandths, or I can remember that decimal's not really doing anything, so I could rewrite it as 27 and 55 hundredths. Now that required me to do some kind of tricky math work where I was moving by place value places to reflect my hundredths and my tenths. So I want to make sure that that actually makes sense. I'm going to go back to my whole numbers. I've got 7 and 25 hundredths. That's going to be like, if I thought of that, like what number is that close to? It's like 7. I'm rounding down. And then my next number, I have 3 and 8 tenths. And that 8, if I was going to round this to the nearest whole number, that 8's pretty high. So that would be like around 4. So I could think of that like I should estimate that it would be close to 7 times 4. And 7 times 4 is 28. And when I look at my final answer, I've got 27 and 55 hundredths. That's really close to 28. So my decimal work seems reasonable. Now, even still, that was really complicated. Multiplying, that we're good at, but then when I had to do all this decimal work down here, that felt really complicated. I think I might make mistakes if I try to think of it that way and then go back. So I want to teach you a way to use standard algorithm to do this decimal thinking for us to make it easier. So I'm going to scroll up to the strategy. I know this is what a lot of you have been waiting for. This is where the math gets easier. So the strategy is really similar to the way we were doing our math for skill 6.1. First, we're going to set it up like standard algorithm. So I have this problem here, 12 and 73 hundredths times 9 and 4 tenths, and I'm just going to set it up. 12 and 73 hundredths times 9 and 4 tenths. I know it feels really weird because we just got done adding and subtracting decimals. It feels really weird not to stack the decimals, but we're multiplying. Stacking the decimals is when I add or subtract or compare. For multiplying, I don't have to stress over that. And here's why. Step 2 asks me to ignore the decimal points for now. We're going to deal with that at the end. So I'm going to ignore the decimal points. Next, I just need to multiply with the standard algorithm like I always do. 4 times 3 is 12, 2 carry the 1. 4 times 7 is 28, plus 1 more is 29. 4 times 2 is 8, plus 2 more is 10. 0 carry the 1. 4 times 1 is 1. 4 times 1 is 4, plus 1 more is 5. All right, we multiplied by the 4. Now I need to multiply by the 9. I'll put my 0 the hero since it's a place value higher than the 4. 9 times 3 is 27. Oops, sorry about that. There we go. 7, that was 9 times 3, is 27, so there's my 7. Carry the 2. 9 times 7 is 63, plus 2 more is 65. 5, carry the 6. 9 times 2 is 18, plus 6 more is 24. Carry the 2. And 9 times 1 is 9, plus 2 more is 11. All right, all we have to do is add up these pieces. 2, 16, 6, 9, 1, 1. All right, so we multiplied like usual. Now it's time to consider the decimal. To do that, we're going to count the total number of place value jumps. When we were multiplying a decimal by a whole number, there was only one set of jumps. But for this problem, we're going to count the total jumps. Let me show you what I mean. If I start here on the outside edge, I can go 1, 2. There were 2 jumps on that first number since it was in the hundredths place. And for this one, there's 1 jump because it's in the tenths place. Oops, I should just say 1 jump. Altogether, there are 3 jumps, 2 plus 1. Altogether, I have 1, 2, 3 decimal jumps. So that last step, I'm going to place value jump the decimal into my answer. I'm going to start on the outside and go 1, 2, 3. And that's where my decimal belongs. What we just did there was this work up here. I'm going to highlight it up here when we had to figure out what to do with our decimal since we were multiplying by hundredths and tenths together. That moving of the decimal work that we did up there is what we just did here simply using our place value jumps. So we just counted the jumps. There were 3 and I did 1, 2, 3. And so we get a final answer of 119 and 662 thousandths. And then I can think, does that seem reasonable? If I go back to my original problem, I had 12 and 73 hundredths. I can think that one is almost like 13. And here I have 9 and 4 tenths. And that's close to 9. 13 times 9. 9 times 3 is 27. 9, 10, 11. That gives me 117, and we got an answer of 119 and 662 thousandths. Those are really close to each other, so that helps me double check my decimal work. All right, so let's do a couple try it problems. This has a lot of steps to it, so it can kind of feel complicated, but it's all strategies you've done before. To solve these kinds of problems, we're just multiplying with the standard algorithm, and we're multiplying by powers of 10. All right, let's check out this problem. I have 8 and 37 thousandths times 2 and 3 tenths. I'm going to set it up like standard algorithm, and I'm going to pretend I don't see the decimal points. I'll say decimal points, I will deal with you later. And then I'm just going to multiply. 3 times 7 is 21. 3 times 3 is 9, plus 2 more is 11. 3 times 0 is 0, plus 1 is 1. 3 times 8 is 24. All right, we're done multiplying by the 3. Now I'm ready to multiply by the 2, so I'll put my placeholder 0 since I moved over a place. 2 times 7 is 14, 4. Carry the 1. 2 times 3 is 6, plus 1 more is 7. 2 times 0 is 0, and 2 times 8 is 16. Let's add it up. 1, 5, 8, 4, 8, 1. So I've added up all the pieces. My final step is to figure out where that decimal point goes. So I'm going to count my total decimal jumps. If I start on my top number, 1, 2, 3 jumps, since I'm working in the thousandths place. And then here I have 1 jump. So all together, that makes 4 place value jumps, since I'm multiplied by thousandths and by tenths. 1, 2, 3, 4. 4 jumps total. So then that gives me a final answer of 18 and 4,851 10,000ths. And then if I want to think, does this seem reasonable? I want to check. I can see, well, this number is pretty close to 8. This number is pretty close to 2. 8 times 2 is 16. 16 is not super far from my actual answer of 18 and 4,851 10,000ths. All right, we have one more try it together. As always, you can work with me, or if you'd like, you can pause the video, try it out on your own, and then watch the video to check your work. All right, just like the last one, I am going to set up the problem. 0 and 874 thousandths times 6 and 2 tenths. I'm going to set it up, and I'm going to be like, I see you decimals, but I will deal with you later. And I'm just going to multiply. 2 times 4 is 8. 2 times 7 is 14. Carry the 1. 2 times 8 is 16, plus 1 more is 17. 2 times 0 is 0. Okay, and then add 1 is 1. All right, I'm ready to multiply by the 6, so I'll do my placeholder 0. 6 times 4 is 24. Carry the 2. 6 times 7 is 42, plus 2 more is 44. Carry the 4. 6 times 8 is 48, plus 2 more is 52. 2. Oops, carry the 5. 6 times 0 is 0, plus 5 is 5. All right, I did the multiplying. Now I can add it up. 8, 8, 11, 1, 2, 3, 4. Uh-oh, my pen is not working. There we go. and 5. So I did all the adding. Now it's time to do my decimal work. I multiplied using the standard algorithm. Now I'm ready to multiply by powers of 10 to reflect my decimal thinking. In this top number, 1, 2, 3, 3 jumps. And in the bottom number, 1 place value jump. So altogether, I need to move my decimal point 4 places to reflect that I multiplied thousandths times tenths. So I can start down here. 1, 2, 3, 4. 4 jumps. And I get an answer of 5 and 4,188 ten-thousandths. And if I think about it, that makes sense because I started with 0 and 8 tenths. That's close to 1. And 6 and 2 tenths is close to 2. 1 times 6 is 6. That's pretty close to 5. And 4,188 ten-thousandths. So this is our new strategy. This can feel like a big jump, no pun intended, for a lot of students. So if you're feeling confused, we can keep practicing. But try to think about the steps and try to think about how it connects to when we were multiplying and dividing by powers of 10 earlier in the year. All right, go ahead and continue in your Canvas module.